Okay, hello, this is 5-6. Now we are going to spend 3 days on 5-6 going over each of the 3 different types of transformations. So a transformation, if you think about a transformer is like Optimus Prime, a transformation is a change, right? So it's something that changes a figure. So today we're going to talk about translations. Another word for a translation is a slide. So when something slides from one location to another, the important thing to remember is that the shapes are going to stay the same size and shape. So they are going to be congruent. Okay, so rules that we have that are going to help you out a little bit for coordinate notation. This is called coordinate notation. What do I do with the coordinates x and y? So if I'm moving something to the right, a certain number like a units, what I'm going to do to the coordinates is I'm going to start with the x coordinate. And if I move something to the right, that's affecting the x coordinate, right? Because the x-axis is the one that moves left and right. And the right is the positive direction. So what I'm going to be doing is taking the x coordinates and I'm going to be adding the a value, however many units we're moving to the right. The y value is not going to change, okay, because we're only moving it left or right. We're not moving up or down. If I were to move a point left a units, okay, I'm going to again be affecting the x coordinate because that's left or right. But now when I move something to the left, that is the negative direction. So we're going to be subtracting a from all of the x coordinates. And again, the y coordinate is not going to change. Okay. Now what if I were to move up instead of left or right? Up is now affecting the y axis, right? Or the y coordinate. So in this case, the x is going to stay the same. But now my y coordinate would change. So if I'm moving up, that's positive. So I would be adding however many units we're moving up. In this case, it's b. I'm adding that to the y coordinate. And if I'm moving down, I think you're going to figure this out. It's not going to affect the x coordinate at all. Down is the negative direction. We're moving down. So we are going to be subtracting that b amount from the y coordinate. Okay, so this says here for our practice, we're going to be graphing the image of triangle ABC after a translation 3 units to the left and 4 units up. Okay, so how is that going to affect our triangle? So we're going to write the coordinate notation, which is this, for this translation. So whatever coordinates we have, x and y, okay, that's going to map to, that's what that arrow means. It's going to map to. Now, if I'm moving 3 units left, okay, so left is going to affect the x coordinate because that's left and right. And left is the negative direction. So since it's 3 to the left, I'm just going to subtract 3 from all of the x coordinates. And the y, I'm moving 4 units up, so I'm going to be adding 4 to all of the y coordinates because up is the positive direction for y. Okay, there's 2 ways to do this. I could use the rule, or I could simply go to each one of these and move each point 3 units to the left and 4 units up. Okay, and that would work, but I would have to do the same thing for each of the coordinates. But let me show you how it works with the rule. Okay, so originally point A is at the coordinates positive 1, negative 1. So if I apply the rule, okay, that's going to get me to A prime. Okay, applying the rule, I'm going to subtract 3 from the x coordinate. So 1 minus 3 would be negative 2. And then I'm going to add 4 to the y coordinate. So negative 1 plus 4 is positive 3. Okay, so A prime, remember prime is going to be what happens after. It's called the image. This is our pre-image. What happens after transformation is called the image. So negative 2, positive 3 is going to be the location of our A prime. And again, that makes sense because if I simply take A and move it 3 to the left and then 4 up, okay, I get A prime. All right, B, the original coordinates are at positive 1, negative 3. And then C, the original coordinates are at 1, 2, 3, 4, and then negative 3. Okay, so to figure out where B prime is going to be, I can apply the coordinate notation. So I can substitute 1 for x. 1 minus 3 is negative 2. And then negative 3, I'm going to substitute for the y. Negative 3 plus 4 is 1. So b prime should be at negative 2, positive 1. Okay, and then finally c, if I subtract 3 from the x-coordinate, 4 minus 3 would be 1. And then if I take the y-coordinate and I add 4 to it, negative 3 plus 4 is 1. So c prime is going to be at 1, 1. Okay, now I'm going to use a straight edge because I want my two figures to look congruent. They should be congruent if I have a correct transformation here. Okay, so you're going to see all we did was slide ABC to the left and up, and that is the resulting triangle. They should look identical. Okay, so this one says graph the translation of triangle ABC, 2 units right and 3 units down. Okay, so 2 units to the right, that's affecting the x-coordinate, and right is a positive, so we could add 2 to the x-coordinate of each vertex. And then 3 units down, down is the y direction, and it's the negative. So we could subtract 3 from the y-coordinate, okay? So when I look at the original triangle, A is at negative 3, positive 4. B is at 0, 2. And C is at negative 2, positive 1. Okay, so now I'm going to apply the rule. So the rule that we're using, again, is we take the x and y, and we're going to be adding 2 to the x-coordinate, and we're going to be subtracting 3 from the y-coordinate because it's 3 units down. Okay, so here we go. Negative 3, we're going to add 2, and 4, we're going to subtract 3. So each time we're going to add 2 to the x and subtract 3 from the y. Add 2 to the x, subtract 3 from the y. So here, negative 3 plus 2 is a negative 1, and 4 minus 3 is positive 1. Okay, for b prime, 0 plus 2 is 2, and 2 minus 3 is a negative 1. For c prime, negative 2 plus 2 is 0, and 1 minus 3 is a negative 2. So now I can go up here and graph these points. Negative 1, positive 1 is going to be where we color a prime. B prime is at 2, negative 1. And C prime is at 0, negative 2. Okay, make sure you put your primes in there when you're labeling the new coordinates. Okay, and again, your two triangles should look identical. It's just one of them is slid to the right and down. Okay, all right, the next one says graph the translation of the quadrilateral, 3 units down and 5 units to the left. Sorry, I lost a big stack of papers here. Okay, so we can go through all of this, but another simple way is just to simply follow this rule with each point. Okay, so I could start at A and go 3 down, 1, 2, 3, and then 5 to the left. 1, 2, 3, 4, 5, and that's going to be the location of my A prime. Okay, for B, again, I'm going to go 3 units down and then 5 units to the left. And that's going to be my B prime. For C, again, 3 units down and then 5 to the left. And then D, follow the same procedure, 3 down and then 5 to the left. And that will be the location of my D prime. So if it's on a graph and they just tell you how much to move down and left, it's probably faster to do it this way. If they only give you the coordinates and no graph, you're probably going to want to use the coordinate rule for it. Okay. Again, notice that these look identical. It's just one is slid down and to the left. Okay, last part is practicing coordinate notation rules. So whenever I write coordinate notation rules, I always start with x comma y maps to, okay? And then we write the rule in the next set of parentheses. So 4 units to the right, right is going to affect the x coordinate, and right is a positive direction. So I'm going to write x plus 4. Okay, 3 units up, up affects the y coordinate, and up is positive. So I'm going to write y plus 3. Okay, the next one, again, we always start with x comma y maps to. So the x, 2 units to the left, left affects the x in the negative direction. And then 5 units up, up is the y, and it is positive. So I'm going to write plus 5. The next one, again, start with x comma y maps to. Okay, so for the x, it's 1 unit to the right. Right is positive direction, so I'm going to write plus 1. And then 6 units down, we're going to write y minus 6 because down is the negative direction. Okay, the next one is just 9 units down. Again, we're going to start with x, y maps to. Now, if it's affecting just up and down, that's the y coordinate. It's only affecting the y coordinate. So we're not going to do anything to change the x coordinate. We're just going to leave it as x, okay? So the y coordinate is being affected. Down is negative, so I'm going to write minus and 9. Right? So now the next one is 4 units to the left. So x, y is going to map to, okay? So it's going to map to 4 units left affects the x coordinate. So it's going to affect the x by subtracting 4. But notice it's not moving up or down at all, so the y coordinate is going to stay the same. Okay, last, can I write the coordinate notation by what's going on here in the graph? So to figure that out, all we really have to do is kind of figure it out for one set of corresponding vertices. So from R to R prime, for example, R is the original, R prime is the final. So what I'm going to do here is figure out how many I have to move this direction and then how many I need to move that direction to get there. So first of all, it's 1, 2, 3, 4, 5, 6 to the right. And then it's 1, 2, 3, 4 down. Okay, so now that I've figured that out, I should be able to do it just like I did the rest of them. So this one is going to be x comma y maps to. Now 6 to the right is going to affect the x in a positive way to the right. And then 4 down, down is the negative direction, so I'm going to write y minus 4. Okay, please let me know if you have any questions on translations.